as you get it done because you would just do it, right? The only reason we have to have due dates is, I'll use a fancy pants word here, it's called extrinsic motivation. There has to be something on the outside making you get stuff done. Intrinsic motivation is inside of you saying, I should do this because I should do this. Extrinsic is I should do this because otherwise it will end up in math and I will get in trouble. Yeah, so grab one of each of these. So we're going to put the card deck in the sheet protector. So this, the card deck and the dice rolls, we're putting this in the sheet protector because you can use this for your homework. You can use this on a test. You can keep this and cherish it forever. But hold up, before we actually slide it all the way in, there's actually a question on the bottom. Let's talk about the question on the bottom down there. So everyone look at this paper. You should have a sheet protector with it. If you don't, grab one. If you don't have a sheet protector, grab one. We'll talk about homework answers in a second, but I want to let you put this in the sheet protector. So if you already put it in, slide it back out for a second. So guys, this is a full standard deck of cards like we talked about yesterday. The information that we wrote down, don't worry, I made the other class write it down also. It's not like they got off easier because I did have this done by yesterday afternoon. But they wrote this down also. We wrote this down yesterday. And the printout that I found, most of the problems that we do, ace is a 1. It plays as a low card. But in some games, ace is your high card. So that's why I wrote this here. Ace can be thought of as a low card or high card, and sometimes both. In blackjack, it actually plays as a 1 or an 11. And I'm sure there's other games where it plays as multiple things because the ace is just kind of special. So this is your standard deck of cards information. We have to know the question to figure out the probability. But when we talk about rolling 2 dice, 2 number cubes, thank you, Miss Martin, we can actually talk about that probability just by looking at the situation because we can figure some stuff out. So take a moment and look at this. Look at the table, look at those results. I forgot I put these way up on the shelf, so I gotta grab these. So, I love dice. If you're a nerd like me, maybe you've seen dice that have more than 6 sides. One of the famous dies is a D20, meaning it has 20 sides. It kind of looks like a golf ball, but it only has 20 sides. I don't know that I have a D20 quickly available. I have a bin full of dice over there if you want to play with dice or check out stuff. There are also dices that are not cubes. I forget if I have those in here or not. No, I'll have to get those back out. So we don't have enough time today to talk about all the weird dice. But guys, if we're rolling 2 dice, here's the thought that you have to have in your head. There's 2 different dice. So what I want you to do over here is label like dice 1 or dice A, and then dice 2 or dice B. It's 2 different number cubes that we're saying that we're rolling at the same time. And yes, a single dice we would probably call a die, but I don't know. I don't really like writing down the word die, so I'm going to just keep using the plural, dice. What's the lowest number I can get when I roll 2 dice? A 2, because the lowest number I can get on each of them is a 1. How many ways are there to make a 2? Just one way, right? Because if I switch these around, it's still that each of them has a 1. And this is why I really like these colored dice that you can see. There's dice 1 and dice 2. If I bump this guy up to a 2, and actually, fun story, you can always go to an adjacent side. Like 2 will not be on the opposite side of the die unless your die has been made wrong. So die should always have 6 on the opposite of 1. 3 is opposite 5, 4 is opposite 2. It's this interesting thing. So if I bump this up to a 1, is this the only way to make a 3? No, because I could also make a 3 by doing this. So this is 3, and this is 3. Right? So there are actually 2 different ways to make a 3. This is why we say results Results are our sum. It's when we add them together. But the outcomes, guys, we say when we roll 2 dice that there are 36 outcomes. And that's why over here, there are 36 little boxes with the sums written inside of them. There are literally 36 different results when you roll the dice. Sorry, outcomes. I need to keep my words squared away with each other. So, there are how many ways to make a 3, did we just say? 2. I'm going to go ahead and highlight this over here. There are 2 ways. So, can't get the 4. There are 2 ways to make a 3. What other number has an equal chance as 3? I should random card. Because the hands that get raised are the same. When I see John and Lucas, I'm like, okay, the people that I call on a lot of times. So, oh my gosh. Lucas. 11. If you look at your table, find the other result that only has 2 ways to be made. And the reason that happens is I can do 5 and 6, or I can do, turn these the right way, 6 and 5, right? 5 and 6, or 6 and 5. These are actually 2 different things. So if you were going to place a bet on the sum when you roll these 2 die, what number, well, that's really funny. What number would you bet when you look at this table over here? What's the most likely result? 7. 7, it has the highest chance of happening because it has the most ways to add up to it. 6 and 1, 5 and 2, 3 and 4, and then turn those around. 4 and 3, 2 and 5, and 1 and 6. There are 6 different ways to make a 7. But if you're not allowed to bet on a 7, what other number, hold on, I'll do random cards. Oh my gosh. Guys, I can't even plan this. Lucas was the first card of today, and John is literally the second card. John, if you're not betting on a 7, what number would you pick? Ah, you said both. John went ahead and let the cat out of the bag. I was hoping he would just say 6 or just say 8. But yeah, if John picks 6 and somebody else wants to pick something equal to that, 8 is also equal to that. What are the hardest numbers to make? Just shout it out. 2 and 12, right? There's only one way to make a 2, one way to make a 12. Does this make sense? If you want to down here write a little note about the things that have equal probabilities, I highlighted, so this is kind of color-coded. I could add more highlighting if I want to. What has equal chance of 5? 9 has equal chance of 5. And then 10 and 4. Right? I am running out of colors of highlighter. So, here's how we would write this, and how your homework is going to write this, but I want you to be comfortable with this. We would say P of, and then you put the number that you're trying to get. So how many ways did we just say there are to make a 10? 3 out of, how many total outcomes did we say are possible? 36. Who has a question on why we just wrote 3 out of 36? There are 3 ways to make a 10. Because 5 and 5, right? And then 4, 6, and 6, 4. And there are 36 actual possible results. Guys, using colored dies helps us think this through. If they're both the same color, it doesn't make as much sense in our brain of why 4-6 versus 6-4 is different, but they are different. right? And I tried to write that down here, like 1/6 is different from 6/1, right? 1/6 is different from 6/1. And then we could reduce this fraction. What do 3 and 36 both reduce by? 3, because 3 only reduces by 3. And we get 1/12. So what's equal to 10, though? What other probability has equal chance? 4, right? So I'm just going to go ahead and over here say, oh yeah, and that's equal to the probability of 4. Because 10 and 4 both have the same amount of ways to happen. Vincent, you with me? I know you might just already have this all written down. Now, if you're happy with that, put that in a sheet protector. It is not hole punched on purpose, because I want you to keep this and be able to find it real quickly in your binder. Guys, I don't know if I talked about Grandma in this class or not, but, you know, my Grandma Wolford, rest in peace, would not like that I'm teaching using decks of cards, but that's because she didn't understand that, like, not every game is gambling, right? So I'm not encouraging you to gamble. My sister-in-law works for the company that owns the Columbus Casino. And let me tell you, if you've ever been in a casino, it's super duper fancy. You know why? Because they take all your money. The casino is made by people that understand math. They know all of this, and the advantage, mathematically, the advantage is with the house. That's what they call the casino. When you lose, and you lose your money, you lost it to the house. So as we talk about probability, please do not think that I'm encouraging you to gamble. Like, casinos are a bad bet. Going to a casino is a bad bet. What I want you to be able to do is look at my rack of games over there, pull one out, look at the rules of the game, and go, I've got a strategy because I understand math. One of my favorite games ever is called Settlers of Catan, or Catan, depending on how you pronounce it. And it all comes down to dice rolling. When you roll a 7, the robber moves. But then all of the other numbers, I'm going to end up talking about Catan for too long if I don't control myself. All of the other numbers are out on the board. I have to show you a picture if this makes sense. Last year I had this in my slideshow, but I lost it. I made a new one. So this is the picture I used last year. I know. So this is how the board of Catan looks. You are building adjacent to numbers, and when that number gets rolled, that's when you get that resource that you've built on. So when I'm deciding what numbers to build on, I'm thinking about the probability. And actually in the new versions of the game, they made the lower probability numbers. What'd they do? They made them smaller and compare 12 to 8. What's the difference in how thick the number is? This is why I love this game. Anyone see what's beneath the numbers? There are little dots beneath the numbers. You know what those dots are? The probability. Boom! Mind blown. Guys, this game has probability built into it. Look at the 11. It's got 2 dots under it. How many ways are there to make it 11? 2. Do you see any 7s on the board? No, because it's not fair, because the 7's like the most powerful number in a dice game. So we've got 8s and 6s. How many dots are beneath the 6? 5. How many ways are there to make a 6? 5. Guys, probability is everywhere. And I'm not saying that you're going to grow up and be a board game nerd like me, but you're probably going to, have some sort of situation involving probability. That I pretty much can guarantee. So there's our deck of cards. Please keep this out because we're going to answer a couple card deck problems. So on your graph paper, if you would, please, we are finally actually in 5.2.1. We're still in it. We were in it yesterday, but we're still in it. So if you want to head your paper 5.2.1, the biggest thing that I care that you have written down is probability. so I don't even care if you put a number on it. Just make sure your paper says probability. It's getting warm. Don't heat up my classroom. Oh, homework. We should probably talk about homework. Absolutely. You can always come in. So you may not have this done yet, and it does not need to be done yet. And actually, let's just check this tomorrow or at the end of class. Like, I don't want you to freak out about like needing it to be done or trying to write down answers right now. We've definitely slowed down. 521 is not due until Friday, and I might even push this to Monday. But like, we'll take any questions. We'll finish up your homework tomorrow. Don't leave it all undone. Do whatever you can do. But let's check that tomorrow because we've got some things to talk about. So we got to start with a vocab word. Sorry, we've got a tad bit of writing to do today. I'll keep it as short as possible. When we're talking about probability, we often talk, well, not often, we always talk in like this certain notation. So let's say we're talking about like the probability of a club happening. So we're talking about a deck of cards, right? Go ahead and write that down if you will. And we're going to just like define, this means probability of a club. Except I don't know how you spell club. But sometimes, especially when we're talking about like weather or different things like that, did everyone get a 522? I know we have a lot of people absent, but if you didn't, they're going to be over here. But I feel like I have a ton of extras. Maybe I just accidentally made too many copies or something. Sometimes you're on the other side of this situation. So let's say Jesus is playing a game. And Jesus, you got some siblings? Who would you play a game against? Your older brother? So Jesus is playing against his older brother. His older brother is going to gain points if he gets a club. Do you think Jesus wants his brother to get a club? No. So in Jesus' head, he's thinking, what's the probability of it not being a club? This is what we call a complement. This is what we call a complement. And not compliment like your hair looks great today. Although your hair does look great today. But complement is what we use for the rest of the situation. And guys, we use complement a bunch of different ways in math. So that's why I don't want you to define it as like the not whatever. That's not what it means. Complement means the rest of what could happen. So if we want to write that down real quick, that's probably a really good idea. So complement is the rest of what could happen. So if club is the thing that could happen, the rest of it is not a club. If we're playing Catan and I don't want the robber to happen, the robber happens when I play a 7, I want to think about what's the chance of a not 7, right? And I'm holding my breath hoping that we don't have a 7. So there are lots of times that we're thinking about the not or the rest of things that could happen. So, talk with your team real quick. What is the probability of not getting a club? And then, this is going to be a bit tougher. What's the probability of not getting a face card? Try to answer both of those questions. Face cards are, aces do not count as faces, right? Aces don't have faces, so these are your face cards. But all of them, right? Boom, 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 boom. Aces are not faces. one of my favorite units to teach. Ooh, Franco still has his paper out, but you put yours away. You might want to have that resource page out with the deck of cards. You've got tons of desk space. Come on, Kylie. What is club? Sorry, I should call on Antonella. You were my next card. What did we say? Club is a. What's the name? We've got like clubs and hearts and diamonds. Do you remember what that's called? It's on your paper if you want to double check it. Club is a. Starts with an S. It's a suit. Yeah, clubs is a suit. So if we're looking at this paper, we've got spades, hearts, diamonds, clubs. Right? Clubs are the clovers. So if we want to, now Vanessa, be careful. If we want to first think about what's the chance of getting a club, what's the chance of getting a club? 13 out of 52, or, guys, you can go ahead and think a bit easier. How many suits are there? 4. When I go too wide on the screen. So 1, 2, 3, 4. We could say, okay, this has 1, 2, 3, 4 suits, right? There are 4 different suits. So you're right. The probability of getting a club is 13 out of 52, or we could say 1 out of 4. So when we go to the not club, not here, Marina, what's our chance of not a club? You can go ahead and reduce it if you want. And you guys can always pass. Yeah, if you didn't get to it yet, that's totally fine. Kylie? 3/4, because there are 4 total suits. One of them is the clubs. There are 4 total suits. One of them is clubs. The rest are not. So if we get rid of, and I'm just going to do like get rid of, we've still got 3 suits left that are not clubs that Jesus would rather have one of those cards come up. Does that make sense to us? The chance of getting clubs is 1/4. The chance of not is 3/4. So what about, do you guys need more time for not a face card? Need more time? Yeah? All right, take at least another minute or so. Probably not a face card. Not a face card. Not a face card. Yeah. There are a few ways to do this. One, you would need to subtract. The other one, you wouldn't have to subtract. If I count up all my non-face cards. Well, guys, give me your eyes real quick. Aces are actually like 1s, right? So if I think of aces as 1s, How many cards in each suit are not faces? 10. So how many total non-face cards are there? 40. So how we would write this is probability of not a face, kind of weird to say, not face, 40 out of 52, because that's how many total cards are in a normal deck. Questions on that? You could also have done 52 minus 12. If you looked over here and said there are 12 face cards, I want to take them away. So you could have done the subtraction and then put that over 52. Totally fine that way as well. Questions? Now we're going to make it a bit trickier. No. But you're ready for it. You're getting good at this. What would happen to the probability of getting an ace on a second draw if you actually had drawn an ace on the first draw and you keep it? So here's what I mean. I've got the entire deck of cards, regular deck of cards, no jokers, right? I shuffle up my deck, shuffle, shuffle, shuffle. I'll take out the extras, right? So here's my 52 cards. I draw my first card. It's an ace, and I keep it because I want it. What's my chance of getting another ace when I draw again? Talk with your team. I've got so many decks of cards floating around now. Whoa! Eve's up here swearing, saying the bad word. What? I'm not calling on you. I'm just saying you're up here saying bad words. Eli, what's one thing that happens or changes when I got my ace and I kept it? Hey, we're coming back together. There are now 51 total cards because I kept one of them. What? Oh, a bunch of inappropriate people throwing around. I heard it. Yeah, I heard it. Aiden, what else happened when I kept the ace? What else changed? So the total number of cards changed. The number of aces changed. There are only 3 aces left. So, Layla Davis, what is now my probability of getting an ace? Yeah, now, I'm going to say like ace number 2. Right? My probability of getting a second ace is 3 out of 51. The aces changed. The total changed. This is what we call without. Guys, you might want to write this down, because then when you see it, it won't surprise you. This is what we call without replacement. If you keep the card, that is without replacement. So if a situation tells you with replacement, they put it back. Now, when I roll dice, can I keep the dice? No, you always pick up 2 dice and roll them again, right? No one's going to keep the dice. So dice don't have weird situations like this. But card decks, if I'm like, so guys, there's a book I really like. I think Franco read it. There's a movie. It's all about blackjack. And they do this thing called counting cards. And all that is changing probability. It's as you watch cards get handed out, you can recalculate the probability in your head. And if you're really, really smart and can do math really, really fast and you get lucky, you could have a positive outcome in blackjack. But most of the time you're going to lose and the house is taking your money. You shouldn't go gamble. It's a bad idea. Guys, like, true story, because I know some people are like, oh yeah, teachers are just doing the teacher thing. I have been to a casino twice. I have only ever gambled like maybe $100 worth of money. Like maybe. Gambling is a bad idea. And I'm smart. I know math. I could probably count cards. But guess what the casino does to fight you counting cards? 1 deck of cards, right? If we start playing blackjack and I hand out an ace to Eve and we all see it, we all know what the probability has changed to, right? It's 3 out of 51. Guess what the casino does? Instead of 1 deck of cards, they play with at least 6. So now, when you're thinking about how many aces are left and how many cards are left, everything is different because you're talking about 6 decks. And then, once they make it, like maybe a third of the way through the stack of cards, they start over again. They get a brand new set of like 6 or 8 or 10 decks of cards all shuffled together, and they start over again. So even if you know the math, the casino knows the math also, and they fight against you. It's like this whole, like, you know, who can math it better sort of thing. John? Huh? No. Nobody ever wins at the casino. Even if you win, if you keep playing, you'll lose. Like, you'll win maybe once or twice, but the thing is, then you got to walk away, because if you keep playing, you're going to lose. Probability says you're going to lose. So if you win, you got lucky, right? Now, I will, like, guys, I'm always honest with you. Blackjack is one of the better casino games because you actually have a chance at winning because it's fairly random, and the house has to play by certain rules. You don't actually have to follow the rules that house does. That's for another lesson when we have more time. But like the dealer at the casino, they have certain rules they have to follow. That's the only reason that blackjack is maybe not as bad of an idea. It's still a bad idea. You're still going to lose money. You're paying for entertainment, guys. It's like going to the movies. When people go to the casino, they know they're paying to have fun, which I don't think it's fun because you just lost money. All right, let's move on from cards and dice. Ah, crap, one more. Sorry, I lied. Keep that out. Keep that out. You're going to want that out still. Rob and Travis are playing a game. Your paper is set up to show this, right? I printed this paper based off the problems that are coming up. So, Rob told Travis if he picked a black card with a value of 9 or greater, right? Black card with a value of 9 or greater. So we're talking 10s, jacks, queens, kings. Travis would win. If Rob picked a red card with a value of less than 9, Rob wins. Whose team would you like to be on? Talk with your team. Do you want to be Team Rob or Team Travis, and why? You got to support it with the math. You got to be able to give me the math, and you know I'm going to random cards this. If your card hasn't come up yet today in class, your probability of being drawn is increasing. See what I did there? I know, so if I do without replacements, right, if I do without replacement, a bunch of you are already out of the deck. See, all the way back to when John and Lucas started class. We're going to make this even more fun. Out of school. Hey Zeus, if you want to chat with anyone, feel free to hop in with another team. If these are the cards of students who haven't been drawn yet today, what is one of these students' chances of getting drawn? 1 out of 9, right? So, Mia, help us out. How many chances or how many ways does Travis have to win? Well, so you're saying that with a question mark. We can go double check it if we want. So black cards, 9 or greater. So guys, I maybe said this wrong the first time. 9 or greater, right? So 9s count. Let's go double check it on our paper. So 9, 10, Jack, Queen, King. How many of these are there? 5. 9, 10, Jack, Queen, King. How many of these are there? 5 more. So how many total? 10. So Travis's chance of winning, trash can is not normally there, is 10 out of 52. But Rob, what's anyone's chance of getting picked now? Now that I kept Mia's card out? Yeah, I did without replacement, so now it's 1 out of 8. So Isabella, help us out with Rob's chance. You guys still figuring it out? You're good. Let's do it together then. Because if you didn't understand it, it's probably my fault. Rob will win if his value is less than 9. So like ace up to 8. But red. So let's go count that. Reds. Guys, this is why I printed this for you. Right? Color, ink, and everything. Reds, less than 9. So there are 8 here and 8 here. What's 8 and 8? 16. So Rob's chance of winning is going to be those 16 out of 52. Guys, whose team would you rather be on? Rob. Farah? So, less than 9. This is the tricky part. Less than 9, and this is 9 or greater. So this, Travis counts the 9s. Rob does not. We had to carefully read there. So if that tripped you up, just be careful with reading. You're totally fine. That didn't say anything about math. This is just the trickiness of reading. Questions? So, do Travis and Rob have a fair chance at winning? No, because Rob obviously has the advantage. All right, so let's talk about blowing stuff up. I told you we're going to put the deck of cards away for a minute. So, at the 4th of July, so just wait, because we only got like 3 minutes left, then we'll put everything away. At the 4th of July, people buy tickets to scratch off for a special section and take a reveal whether they won a prize. 1 out of every 5, seems important, get a free entry into a raffle. Okay. So you won a chance at the raffle. Then, 2 out of every 15 people who play win a small cash prize. So, and we'll probably, I'm going to give you a couple minutes to work on this. We'll probably just start with this tomorrow and do a couple questions before we do your mini mastery. And actually, I should show you the mini mastery here in a second. Yeah, we'll do this problem tomorrow, or we'll start the week with it. I want to show you what's on your mini mastery so you know what to expect. So if your eyes are not up front, that's your choice. Question 1. Mr. Beck is shopping at the Book Loft. They're having a 20% off sale. Here's the original price of his book. What is the new price? Show me how you find the discount and the new price. Miss Howard is at the science shop. She's going to buy a new shrink ray. They tell her that she only needs to put 10% down. So she pays 10%, which is $450. That is 10%. How do we figure out the total price of that shrink ray? MC Crafts, Macy and Caitlin are having a sale. This is true. I don't know if the sale is still going on, though. They have 50% off their stickers. If Mr. Estes buys a sticker that's normally $7, what did he pay during the sale? Do not use the bad word. I can read your thoughts. Some of you are thinking the bad word. Quit thinking the bad word. MC Crafts realizes they made too many mini yarn hats. They changed the price from $6 down to $5. What percent did they change their price by? You're also not yelling the right answer, so don't say anything. The News Club decides they would like 25% of their broadcast to be commodity. They have 2 minutes of commodity ready for the broadcast this week. How long should the entire broadcast be? Mr. Hudson has a coupon for Home Depot. If he saves $35 off $175, what percent is that? But he spends more, and he actually ends up spending $233 and getting $35 off of that. What percent is that? That's the entire mini mastery. Have a wonderful Thursday. Woo! It's like speed round.
Am I allowed to turn in the chapter 4?
Absolutely. You can turn in anything you want, really. At this point, I just sort all the papers.